Now, after average ratio, uh, harmonic mean also helpful in finance and investment. As in finance, the harmonic mean basically used to calculate the average of multiples like price to price earning ratio, which is PE ratio, of a portfolio of a stock. It is used when the average of ratios need to be computed. When we have to calculate the average of different ratios under finance or investment, then we have to use harmonic mean for calculating average. Okay, so add harmonic mean is used for calculating average, and when we have to calculate the average of different ratios like price earning ratio, then will use harmonic mean as it is most convenient method and useful method for calculating averages. Now, next is efficiency ratio. As harmonic mean is useful in scenarios where the data set includes efficiency ratios like cost per unit ratio or output per unit ratio. So for calculating basically ratio or for calculating when we have to we have to given a data set which include efficiency ratio, then in that case we use harmonic mean. As harmonic mean basically is the best measure to calculate the average. Now let's come to the advantages and disadvantages of harmonic mean. So, if we talk about the advantages of harmonic mean basically is appropriate for rates. It balance outliers. It reflect true value of average as it is a more appropriate method or more appropriate measure to calculate the average, and it is basically useful in diverse fields. Okay, and it is also mathematical sound for certain, as it is mathematical sound for certain type of data. So now let's discuss all the advantages in detail. First is as it is appropriate for rates. So what we understand from this is that harmonic mean basically provides a more accurate measure of central tendency for rates, or you can say for calculating ratio or for compared ratio or to arithmetic mean, especially when the data set includes values that represent basically speed, densities and other weights. So it is very appropriate and it provides accurate measure of central tendency when we calculate rates or when we calculate ratios which are as compared to the arithmetic mean. Basically, in harmonic mean, when we calculate rates or average, the data set basically represent the values in speed, in densities, and in other rates. Okay, next point is balances outliers. So, harmonic mean gives less weight to the larger outlier and the more weight to the smaller values, or you can say larger values, less weight, smaller value, more weight. And basically, it give advantage to certain context. The harmonic mean basically give less weight to the large outlier and the more weight to the smaller values. This is particularly useful when small values are more significant in the context of the data. Uh, let me let us consider an example for calculating average cost or efficiency where lower value are more critical and the harmonic mean basically prevent the large outliers from the uh, disappropriately skewed. Okay, so it is very helpful basically in balancing the outliers, as it provide less weight to the larger values and it provide more weight to the smaller values. So basically it make the calculation easier in harmonic mean for calculating average for any given data series. Next is it reflects true average. So basically, harmonic mean basically provide a true average value for situations which involve inverse relationship like speed and travel time. So in this case, the harmonic mean basically give a true average that better represent the data. So what we understand, when there is a inverse relationship uh, like speed and the travel time. So in that case, harmonic mean gives a true average, then the better for the better representation of the data. So for the data which involve inverse relationship like speed and time, basically harmonic mean provide an accurate measure of central tendency. For example, when we have to average the profit earning ratio of multiple companies in stock portfolio, so we use harmonic mean, which give a better representation of the representation of the uh, portfolio which is parallel electrical, which represent the portfolio's overall valuation. So when we have to average the profit earning ratio of multiple companies in a stock portfolio, so it gives a better representation of the portfolio's overall valuation. So this is how it reflects the true value of the average. Next, it is useful in diverse fields. So basically, harmonic mean is utilized in various fields, like in engineering, like in finance, in economics. Basically, in finance, this harmonic mean is used to calculate the average price earning ratio of a portfolio in engineering, which is used to determine the average of parallel electric circuits. So, this is how harmonic mean is useful in diversified field. Now, next is mathematically sound for certain type of data. So for data set which values are fractions or rates, the harmonic mean provide a mathematical sound average to those type of data. So for calculating the average price per unit in bulk purchase scenario where quantities vary from one price to the different price, in that case the harmonic mean is very useful for calculating average. So harmonic mean done the calculation mathematically, which is very useful for certain type of data, like data type may be in fractions or in rate. So this is how harmonic mean help in various scenarios. Now let's come to the disadvantages of harmonic mean. So disadvantages of harmonic mean is sensitive to zero value, it is limited applicable, it is a complex calculation, it is less intuitive, there is no robust code database with higher value, and it required positive data. So these are the basically disadvantages of harmonic mean. So let's discuss this disadvantages of harmonic mean in detail. First one is sensitive to zero value. So harmonic mean cannot be used in the data set which contains zero value, as this make the calculation undefined and improper. Like we have discussed in geometric mean also, geometric mean also cannot be applied on the data set in which value contains zero. Similarly, harmonic mean cannot be used if the data set contain zero values, as it provide a calculation which is undefined. Okay, so the harmonic mean basically highly sensitive to the zero value, because the reciprocal of zero is undefined. As in calculating the harmonic mean, we have to take a reciprocal of the given data series, and when there is a zero value, the reciprocal of zero is undefined. So when there is a zero value in the data set, it makes the harmonic mean calculation impossible if any data point is zero. So while calculating harmonic mean, the value should be positive and there should be no value in data set is zero. So if in a data set or any data set representing the speed, if one of the speed is zero, okay, so in this case the harmonic mean basically become undefined. So making it impractical for such data set. Calculation for calculating average or calculating harmonic mean for this type of data set is impractical. So this is not applied on the data set in which value contains zero. Next is limited applicability. So, as in harmonic mean, it is not always appropriate for data set that are not rates or not ratios. It limit its journal use basically. The harmonic mean basically is not suitable for all type of data. So particularly those that are not rates or that are not ratios, it is only used in limits to specific scenario where the data is better represents by the harmonic mean. So the applicability of the harmonic mean is very limited, as you cannot apply harmonic mean on every type of data set. Okay, so if some point or some topic have its advantages, so it also have its disadvantages also. So harmonic mean basically not apply on zero values, and it is not applicable on some sets of data. For example, for data set which represent quantities like income or population, the arithmetic mean or median might be more appropriate for these type of data. For these type of data, you cannot apply harmonic mean. So when you have given a data set in which income and or population are given, you should apply arithmetic mean, median or mode for the calculation of central tendency. You cannot use harmonic mean. In that case, as it provide you inappropriate result uh, for the calculation. Now complex calculation. Next disadvantage of harmonic mean is complex calculation. So like the geometric mean, harmonic mean is more complex to calculate as compared to the arithmetic mean, which might be less, or you can, which might be less important for some users. Okay, the calculation of the harmonic mean is more complex to the arithmetic mean, as it requires the reciprocal of the values and the reciprocal of the values of their arithmetic mean. So when we have to do the calculation in case of reciprocal, so it make it more complex and it make it more difficult. As while calculating the arithmetic mean, you did not require the reciprocal value of a data set. So we can say that when a large data set manually calculate the harmonic mean, it can be there are some problems, or it can be some prone to error, required computing tools for accuracy in case of harmonic mean. Next point is it is less intuitive. So, what is intuitive mean? Basically, it is the ability to know or to understand things without any proof or any evidence. So, in this context, we can say that the concept and interpretation of the harmonic mean basically can be less intuitive for individual who are unfamiliar with its applications, and it make it harder to understand the communication. So, many people who are not familiar with the concept of harmonic mean, so they are unable or they cannot understand the procedure or the calculation of harmonic mean without any proof or without any evidence. Okay, so there is a requirement of all these things, proof or the evidence in the calculation of harmonic mean. So, for explaining the significance of the harmonic mean to stakeholders who are not well aware about the statistics might be challenging, especially in comparison to the more straightforward arithmetic mean. So, this is how harmonic mean is less intuitive. Next is not robust for data set with high variability. So if in the data set basically with a high variability or very high values, a harmonic mean might not be robust and can produce misleading result. So in a data set, when the values ranging from 1 to 1000, the harmonic mean will be disappropriately affected by the smaller values. So, which potentially misrepresent the center tendency of the data. So, basically, harmonic mean is not robust for the data with high variability. Next is it required positive data. As we have discussed in geometric mean, for calculating these both geometric mean and harmonic mean, the data should be positive data and there should be no zero value in the data set. You can only apply or you can do the calculation of harmonic mean and geometric mean only positive data. So the harmonic mean can only be applied to the positive numbers. Negative value or value including zero are incompetent with the calculation. So for financial metrics that can make or that can take negative values also. So for in that case, harmonic mean is not applicable. So these are the some disadvantages of harmonic mean. As we can say that harmonic mean basically is a value of statistical tool in business statistics, especially when we are dealing with rates, with ratios and efficiency metrics. So its ability to accurately reflect the average of rates and balance the impact of extreme values, which are very useful for measuring central tendency in specific context. So the limitations such as sensitive to zero value and complexity of its calculation should be considered when determining the basically determining its appropriate to a given data set. So this is the concept of harmonic mean and geometric mean. Now we will further cover three more topics of this unit. Understand the concept of quartile, percentile, and decile. We will also discuss the advantages and disadvantages of quartile, percentile, and decile. So before discussing these three topics in details, so let's understand the concept of this. So basically in statistics, we commonly encounter the concept of the median, which represent basically the mid value or mean of two middle value in a data set. So when you have given a data set, you have to arrange the data set in a particular order, and from that data set you have to identify the mid value. That middle value is your median. Okay, so we use this method to measure the central tendency under statistics. So, however, there are some other essential values which divide the data into equal parts. Okay, for more appropriate analysis. So, for this purpose, basically we use quartile, percentile, and decile. These three terms also divide the data into some equal parts so that more comprehensive or more reliable analysis can be done. So basically, quartile, percentile, and decile of partial value which represent various representative on the same subject. Basically, to put it another way, there are some values that partial the same collection of observation in several ways. So it can be divided into many equal parts. So according to the definition of the median, in the basically median is the middle point in a middle point in a given series, or you can say it is the middle point in a given axis frequency distribution curve, and it divides the area under the curve into two equal parts, or you can say into two areas with the same area on the left side and with the same area on the right side. So the area under the curve for four equally divided parts of the area, that is called quartile. Okay, when we draw a curve, then the midpoint of the bell-shaped curve is the median, and it divides both the parts of that curve into two equal parts, left side and right side. So basically, when the area under the curve divided into four equal parts, that area is quartile. Okay, and the area for which divided into 10 equal parts, that is called decile, and the area which equally divided into part for 100 times, that area is named as percentile. Okay, when we divide area into equal parts, that is median. When we divide area into four equal parts, that is quartile. When the area of 10 equally divided parts, that area is decile, and the area for 100 equally divided parts of the area is percentile. So this is how we do the calculation of quartile, percentile, and decile. First, let's understand the concept of quartiles in detail. So there are several ways to divide an observation when it is required. So when we divide it in two equal parts, basically that is median. When we divide the observation into four equal parts, that is quartile. So to divide the observation into two equally sized parts, the median can be used. Okay. So a quartile basically is a set of value that divides a data set into four equal parts basically. Okay. So when we divide the area into four equal parts, so basically, the first quartile and the second quartile and third quartile are the three basic quartile category. Q1, Q2 and Q3 are the basic three quartile category under the quartile. The lower quartile is another name of the first quartile, which is denoted with the letter of Q1. You can see on your screen also. The median, which is formed, you can say the median, which is another term, this is the second quartile, and it is denoted with the letter Q2. And the third quartile basically often referred to the third part of the area, and basically it is denoted by the letter Q3. Okay, so when we simply put the values which are divided in a list, or which are basically divided in a list of numericals, data into three quartiles are known as quartiles. Okay, so the center of the three quartiles, you can say quadrants, the center of three quadrants basically measure the center point of the distribution and display the data that are close to the center. Okay, basically when we divide the series or area into four equal parts, that is quartile. So three important quartiles are Q1, Q2 and Q3. So Q1 is the first quartile basically, and the median of the lower half of the data is 25th percent. In Q1, the data is 25%, and second quartile is denoted with Q2, which is second quartile, and we can say the median. Okay, which in which the median of the entire data set is 50%. Okay, in Q2, it is 50th percentile data. In Q3, that is denoted with Q3 is third quartile basically, in which the median of the upper half of the data, which is 75th percentile. So this is how Q1, Q2, Q3 are defined in basically in quartile. So quartile are three basic or three important in quartile. There are three important quartile: Q1, Q2 and Q3. Now if we talk about the first and the third quartile, so the first and third quartile basically are also known as the lower and the upper quartile. Okay, and if we talk about the second quartile, so second quartile basically represent the median or the middle value of a series or a area. First and third quartile are the lower and upper quartile, and the second quartile is the median or the middle value. So these division help in understanding basically the distribution, which providing insight into the data central value and variability. Basically, quartiles are instruments in constructing box plots, identifying outliers, and it helps in performing basically other statistical analysis. So this is how we use quartiles. If we talk about the application of quartile, so basically quartile is used in various sectors. As quartile is used in data distribution analysis, it helps in comparative analysis, It quartile helps in identifying the outlier. Basically, it helps in statistical forecasting, statistical modeling. Quartile helps in summarizing large set of data, and basically quartile helps in other statistical modeling also. So let's understand the application of, or you can say the importance of quartile. So, when we talk about the data distribution analysis, quartile basically provide a detailed look at the spread and at the central tendency of the data. So, by basically by dividing the data into four equal parts, each contain an equal number of observation. Okay, 25%, 50%, 75%, and 100%. There is a difference of 25% in each value, in each quartile. So basically, each contain an equal number of observation quartile, which give a comprehensive overview of the data distribution. Identifying the outlier. So basically, quartile helps in identifying the outliers. Outliers quartile helps identifying the outliers in the data. When value significantly lower than Q1 or significantly higher than Q3, it can be considered outliers. So these outliers can be visualized using box plot. So as the use of quartile is, we can represent quartile with the graphical representation. So when we plot Q1, Q2, Q3, Q4 on a graphical representation, so the value lower than Q1 and value uh, higher than Q3 means lower than 25% and higher than 75% are considered as a outlier. So value must be between 25% to 75%. So this is how we can easily identify the outlier with the help of quartile. Next is comparative analysis. So, quartile is divided into four equal parts. So, basically, quartile allow for comparative analysis between different data sets. So, by comparing the quartile of two data sets, one can easily determine which set has a significantly high variability, which can be more centered, or which can be more uh, concentrated value. Okay, so the comparison of two data set is very easy with the help of quartile, as we can easily identify the variability among the data set. Next is summarizing large data set. So as in large data set, quartiles provide a concise summary of the data. So rather than examining each data point individually, quartile offer a snapshot of the data for overall distribution. So, quartile basically make it easier for summarizing large data set as it represent graphically. So you can easily represent all the data graphically if it is in large set. Okay. So next is statistical modeling. So quartile basically used in statistical analysis. So if we talk about statistical modeling, so quartile are used in statistical modeling and hypothesis testing basically. Basically in if we are going to conduct a regression analysis for a given data set, then in regression analysis analysis, quartile basically helps in understanding the distribution of residuals. When we apply regression analysis with the help of software, with the help of, for example, SPSS is a software for conducting analysis. It is a tool for analysis in which we apply test on large set of data. In so when we run a regression analysis on a software or a tool, then it create a quartile graph for you, which is a bell shaped graph. So it may provide you better understanding for the distribution of residuals. So this is how quartile basically important play an important role in statistical analysis basically. So quartiles are is a fundamental concept in statistics which offer variable insight into data distribution and variability. Basically, it divide a data set into four equal parts, in which quartile basically helps in understanding the central tendency, and it also helps in identifying the outliers within the data. Okay, so whether through normally calculated or visually represented with the box plot, quartiles provide a concise and effective summary of complex data set. So the application, which is extended across various fields for academician research to business analytics, it make them it make a very easy for them to do the statistical analysis. This is the meaning of quartile.